Welcome to our June webinar, and thank you for joining us. Today is going to be all about moving to x86. My name is Camiel Vanderhoeven. I am the Chief Architect and Strategist at VMS Software, and I do know that many of you already know me as one of the kernel engineers, but I have a new position now, and in my new position, I'm the product owner for OpenVMS. And that means that it's my job now to determine the strategic direction we want to take OpenVMS in, as well as to steer the engineering efforts in that direction. I am joined on this webinar today by a good friend of mine, Norman Lastovica. And Norm is with Software Concepts International, and they were the very first of our partners to receive a very early and I think very buggy version of OpenVMS on x86. Hi, Norm.
Good morning, good day to everybody.
Right. So first, I will be talking about supported hardware configurations and about the tools and resources that we have available to help you make that move to x86. When I'm done, Norm is going to take over and he will share some of SEI's experiences with x86. And then after that, we'll have some time for questions. Now, if you do have a question, you do not have to wait until the end of the session to ask it. There is a Q&A button at the bottom of the screen, or at least there should be. And you can type your questions there. And we will handle all of the questions that we can manage within the time at the end of this session. But if we run out of time, the rest of the questions will be answered later. We'll be making a recording of this session, and we will distribute that along with the slides that we used, as well as the questions and answers. So that will be available after the webinar. So let us talk about supported hardware configurations and tools. But before I do that, I want to remind you of what our mission at VMS Software is. By linking the past to the future, we provide OpenVMS users an opportunity to protect and realize the full value of their application investments. And based on our mission to protect the value of these applications, it was very important that we help our users move away from Itanium, a proprietary platform which really didn't have a future anymore. So our big mission was to get our users onto commodity hardware. So that was the first of the goals that we set. At the same time, it was really important that we preserved all of the features of the operating system that our users really require and cannot do without. And an important one is the ability to cluster systems together with shared storage, and do that in such a way that each cluster node has direct access to that storage. Now, we have succeeded in our goal of running on commodity hardware with the port to x86. But with that accomplishment, we now have an expectation that our software can run on any hardware, that it's vendor agnostic, especially now that we are running in virtual machines like KVM and VMware. So that's become, oh, this goes too fast. So that has become a new goal. So you might wonder, why are we talking about hardware again? I've still skipped ahead. So sorry. So we are running on virtual machines, and that is fairly rapidly becoming old stuff now for our customers. And many of our users are starting to ask us about taking OpenVMS to the cloud. And in many cases, they even want to take their OpenVMS clusters to the cloud. So to answer the question why we are talking about hardware again, I want to take a look at where we stand today with VMS version 9.2-2, update 2. And for the most part, OpenVMS is indeed vendor agnostic. as long as the system meets some minimum requirements, OpenVMS can run using VMware or KVM on pretty much any hardware, whether it's from HPE, Dell, Supermicro, IBM, or some other vendor. We are currently working with one of our customers, and I'm really excited to be able to share this with you. We're working with one of our customers and a cloud provider to deliver a proof of concept implementation of OpenVMS running in the cloud. Note, however, that this is not a cluster in the cloud, and that is because we can't properly do shared storage on x86 yet. Because for users who run clusters with shared storage, the only option currently supported on x86 to access that storage is to use MSCP. And that can result in serious performance bottlenecks for some applications. If you want to access fiber channel disk access in a cluster, you will have to go through one of the Itanium or Alpha systems in the cluster. So I'm not quite putting a checkbox, a check mark into the cluster shared storage box yet. So we are vendor agnostic. So once again, why are we going to talk about hardware today? Let's take a look at what version 9.2-3 will bring, which we plan to release in December after we've done a field test. So for shared storage in a cluster, what we're going to support with version 9.2.3 is directly connecting to the fiber channel fabric, like on Alpha and like on Itanium. And to accomplish this in a virtual machine environment, we're going to use a VMware technology called VM Direct Path IO. VM Direct Path IO is a technology to assign a PCIe controller to a virtual machine. So in our case, this allows the exclusive assignment of a fiber channel controller to a virtual machine running OpenVMS. There's no emulation that gets in between. So to the operating system, it looks like it's running on a system that's got that fiber channel controller plugged directly into it. Now, that will enable OpenVMS on x86 to directly talk to those fiber channel disk and be a fully featured member in a VMS cluster. There's a similar technology available for KVM, PCI pass-through, and we expect to provide support for that in a later update to 9.2-3. There's a big drawback, though. Well, maybe not a big drawback, but there's a bit of a drawback. Once you directly assign one of these fiber channel controllers to an OpenVMS virtual machine, the operating system needs to have the driver support required for that specific fiber channel controller. Unlike other hardware resources that you see on a virtual machine, there is no abstraction layer that gets in between, like with the network cards. And what that means is that you can now have either real cluster shared storage, or you can have the vendor agnosticism that we have today, but you cannot have both at the same time. Also, fiber channel hardware is not something that can be provisioned in a cloud environment. So this means that even when we get to version 9.2-3, we cannot have shared storage clusters in the cloud, unless you're willing to go the MSCP route, of course. So with the picture for December complete, it's time for a few details that you might want to know about. We have chosen to support one fiber channel adapter, and that is the QLogic 16 gigabit fiber channel card as sold by HPE. The HPE part number for that card is SN1100Q. Of course, since that's an HPE provided card, it is only supported on HPE ProLiant hardware. We also expect to qualify the 32 gigabit QLogic fiber channel cards from HPE with a later update in 2025. Now, unfortunately, we cannot easily support other fiber channel adapters. Fiber channel adapters which have an Emilex chip on it cannot be supported because we do not have the proper driver for them. We also cannot easily support non-HPE QLogic fiber channel adapters, even if they use the exact same chip, because what we have found is that each OEM makes small modifications to the firmware on those cards. And we simply do not know the effect that those modifications may have on our clustering capabilities. They would have to go through qualification testing, and that's a fairly lengthy process because we try to be thorough. And that would require the allocation of scarce engineering resources over a prolonged period of time. And what we would much rather do is to spend those researches to take the next step in bringing OpenVMS to the cloud. And we have identified our reliance on fiber channel technology for clusters as the greatest single obstacle to the ability to create OpenVMS clusters in a cloud environment. And to remedy that dependency, we have started a project to provide iSCSI storage for OpenVMS. So we plan to go to field test with an iSCSI solution in the second half of 2025. And that will be followed by a general availability release sometime in 2026. Now, iSCSI provides a disk access protocol that's pretty similar to Fiber Channel, but instead of using dedicated Fiber Channel hardware, it runs on top of TCP/IP. And that means that it can use regular Ethernet connections and regular Ethernet hardware. iSCSI will also work with the virtualized Ethernet providers that hypervisors provide. And that means, in turn, that our requirements of the underlying networking hardware become generic again. That means we have no longer have this dependency on a specific card. And that means that we can have real shared storage and at the same time be vendor agnostic. Also, since we now no longer have a dependency on hardware that typically is not available in a cloud environment, we can now run real clusters in the cloud. And of course, we will keep supporting fiber channel pass-through even after iSCSI has been released, and we will also support running iSCSI on-prem. So let me recapitulate that in a picture. So on the left, where it says now, you see what we currently have for shared storage support. And from that, you can see where we expect to go in the future. Now, of course, the ability to set up a cluster with direct disk access for each member in that cluster is one of the most important features of OpenVMS. And we fully understand that having that feature available on only a single brand of hardware is a disappointment to many people, including us. But what you need to understand is that that is a temporary situation only. And we have chosen to strategically allocate our engineering resources to get you to a fully supported cloud solution using modern storage without any vendor lock-in as quickly as possible, rather than spend a few years adding support for various vendors' hardware. And we do truly believe that this is the best choice that we can make at this time to protect the value of your applications in OpenVMS in the long term. So I hope that is clear to you. And if not, we will see the questions coming, of course. That said, let's take a look at the tools and resources that we have available to help you in your transition to OpenVMS on x86. First of all, of course, in a very literal sense, we have various software tools in OpenVMS that you can use. We've got all the compilers. We have, well, with the exception of Ada, that is, we have development tools like DECset. We have libraries and layered products. And we also have some tools that run on other platforms. One of those is the VMS IDE plugin that runs within Visual Studio Code. and that provides a more modern development environment, which is very useful to people who are new to OpenVMS and need to develop software there. Another thing that you can find on our website is an application evaluation checklist. And this checklist will help you gather all of the information you need to define the scope of any project to port an application to x86. If you want to kick the tires of OpenVMS on x86, we do offer evaluation licenses, and those come with some support. And also on our website, you can find all sorts of documentation, the release notes for all the software we put out, and you can find instructional videos on various subjects around running on x86. You can also get help from your peers using our forums, and you can find some information on our wiki pages. We offer training. We have self-paced training. We have instructor-led training, either on site with you or online. In fact, we have a special summer school program this month and next month, and that means that you can get our online instructor-led training at a pretty serious discount. So if you want to learn more about that or even sign up immediately, you can contact us at training@vmssoftware.com. We also offer consulting services, and through those services, we can help you discover what it is that you have. We find some customers are unclear on what products are installed on their system and which products they're actually using. We can help you with that. We can also help you upgrade to newer versions, and we can help you tune your system. We have an application services team. They can review your applications and make recommendations on how to improve or future-proof your application. They can also help you with application maintenance or even completely relieve you of that task. They can also help you integrate your software with other systems, and they can help you with modernization. And finally, of course, we have VMS partners such as Software Concepts who can help you out. And having said that, it is a big pleasure to hand the microphone over to Norm, who is with Software Concepts, and he's going to share about their experiences with OpenVMS on x86. Norm, over to you.
Okay, so as I was saying, I've since many years ago been involved with moving applications from one architect to another. I worked for a company called Digital. I was involved with some of the early porting of VAX-based applications to Alpha platform. At Oracle, I was involved with Alpha to Integrity porting. And now here at SCI, we've been doing quite a bit of work with VAX Alpha and Integrity to x86. So that's my background. The agenda, what I'd like to cover today, a little bit of history. Camiel mentioned we were the first non-VMS site to run x86. We'll talk a little bit about cross-compilation of applications, a little bit about native compilation, and finally, some of the areas where I've seen that code changes were necessary, and I anticipate your applications in these areas may need a little attention. So from our perspective, a historical view is that we've run on x86 for a long time. We had VAX emulators many years ago. Then we had Alpha emulators, so we could run VMS VAX systems and VMS Alpha systems on x86. There have been rumors of native behavior, native VMS on x86 for a long time. They come and go. They're brought up and they're shut down. VSI enters the picture, taking over from HP, and the rumors get a little stronger. Nobody's committing anything yet. And then those rumors turn into announcements. Announcements turn into software production. So we've had environments where we can, on our integrity systems, build x86 code. In fact, many of the programs that I'm responsible for were compiled and linked long before I had a computer or an operating system to be able to run them on. And then finally, things started to gain some momentum. We had versions of VMS that we could install. We've had native compilers that we can build applications and run applications. And now we've got a production release of OpenVMS. So SCI's original foray involves many, many years of relationships, both personal and professional, with the people who develop VMS, from the digital and compact to Hewlett Packard to VSI. That's where we come from. Those are our backgrounds. And I think as part due to those relationships, I received an email in the spring of 2020 that more or less said, "Are you ready for an experiment?" And so, of course, the answer is always yes. And then we ask, of what? And so we were flattered and appreciated the acknowledgement of our relationships and our experience. So a couple days later, we received a convoluted set of instructions and a couple of zip files. I cobbled together an environment where I could run this container. And so within a couple of hours of receiving the instructions and the software, we were running VMS. And I have to acknowledge that it was a little bit underwhelming. You boot the system, you log in, you do a show system command, it just works. It looked just the same as it would have if I was on a piece of alpha hardware. So from that angle of it, it wasn't exciting. From the other angle was, this is the fourth significant platform that I've run VMS on. And that's pretty neat. So nobody uses computers, nobody runs OpenVMS just because. They run VMS because we have an application. We've got something we need to do, whether it's running the factory or producing the widgets or running a stock exchange or whatever it is that your business does. That's why you run on VMS. And so over the years, as I mentioned, SCI's personnel and SCI as a company has been involved with porting different chunks of applications from one platform to another. And in this particular case, I started porting SCI's internal applications, part of our tool sets and things like that, as well as a bunch of freeware stuff. And then more recently, some real commercial applications coming from primarily integrity, but alpha as well. I can't off the top of my head think of any situations where we've taken a contemporary VAX-based application directly to x86. So going into this effort, having been through a couple of iterations, my expectation was for most user mode, plain old applications that generate the report or do whatever it is your business does, it's recompile and relink. Most lines of code in a higher level language are going to fall into that bucket. So that's the anticipation. That's what I was hoping for. So as I mentioned, VMS is VMS, DCL is DCL. All of the components that you're used to, and I just kind of made a little list here, but they're there, they work, they do what you expect them to do. I've got command procedures that were written in the very early 1980s on VAX VMS that work unchanged today on x86. It just goes. The compilers are mostly the same front end. In other words, the language part of the compiler is mostly the same, regardless of platform. So, whatever, C or Pascal or BASIC or whatever, the language stuff remains the same. There's some big exceptions here, but they're really not all that important right now. So when we went to Alpha and when we went to Integrity, we talked a tremendous amount about data alignment. On VAX, it mattered, just not very much. And by alignment, of course, we refer to having words aligned on word boundaries, long words aligned on long word boundaries, and so on. When we moved to Alpha, we knew it was a little more important, but again, running the application is significant. On Integrity, we talked about alignment a lot. It was very, very important. Got to do lots of changes and fix up alignment faults and all these things. Now we're back to x86, and we're sort of in the VAX days. The hardware and the firmware of the computer chip do a lot of the heavy lifting for us. In most cases, there's no functionality impact. And my recommendation is, unless you have a problem, don't expend any effort trying to change your data structures or your application to deal with this alignment. Just don't worry about it. You can, once you've got your application running in production, we can do some performance modeling and decide, but in the short term, it's not worth it. Floating point is sort of the same software. When we migrated to Integrity, and IEEE floating point was the only thing that the hardware can do, we spent an awful lot of time and effort trying to convince people to understand floating point and understand IEEE versus VAX. Probably we overdid it. It would have been a little bit better if that had been a small topic instead of a big topic, but here we are. My recommendation is, if you can get away with it without killing yourself, make your application use IEEE floating point today if you're on Alpha or Integrity, and then the behavior will be identical when you go to x86. You'll get a little bit of performance benefit because everything will happen in hardware. There won't be any conversion back and forth between formats. One area that I see even recently people getting burned is the system service lib$weight. Just be aware that its default is to use VAX F floating point. I don't know that it's that big of a deal. If you are passing binary format floating point on your network, if you store it in disk, if you're interfacing with a database, then maybe the argument shifts a little bit, and your best bet is to behave just like you do on Integrity. Another area of difference that we noticed is TCP/IP version 6 from VSI is that the majority of it's the same as 5.6 on Integrity, same stuff. However, the SSH interface, which also shows up in SFTP and SCP and a few other fringe areas, is a separate product that you install. It's not part of the base TCP/IP, if you will. You're being promoted to OpenSSH key format, which is great for interoperability with the rest of the planet. A little bit less great if for interoperability with prior versions of OpenVMS. The key content is the same, the format's a little different. And the command line interface is largely compatible. There's a few edge cases that don't work, same, but it works, it gets the job done. And now we're back into the 2020s and hopefully 2030s with interoperability with the rest of computing. Okay, so within SCI, my environment running on x86 is a little embarrassing. I'm actually running VMS on top of Oracle VirtualBox, on top of VMware, on top of some hardware. At the very beginning, this was the most expeditious thing for me to do because I had all the pieces in place already and I didn't have to go to our IT department and allocate new resources. It's not necessarily the most elegant thing to run and maintain, but it works. It's completely functional. I wouldn't necessarily suggest anybody else do this if for no other reason. It's not real fast. And it's provided an incredible source of amusement when we find bugs in VMS and I report them and they want to know what environment I'm running on. And I have to admit that I'm running on this hodgepodge of piled up virtual environments and so on. So yeah, I don't believe we found a situation yet though where a software bug was caused by my environment. We run a multi-architecture cluster is kind of my main testing and development, our main system. And at the beginning of this, it became a little clumsy because since years, we run a VAC 6.2 and an Alpha 6.2 system in our cluster, and that was to ease some of our build requirements so I could submit a batch job and build for VAX executables. With version 9.2 or maybe 9.0, I can't recall, the minimum other member of the cluster version was 7.3. And we went back and forth a little bit internally and decided that we really didn't require 6.2 in our cluster anymore, and kind of kicked the can down the road and said, well, if we do require 6.2, then we'll solve that problem. And that problem will probably be running 7.3 and then compiling and linking our applications against a 6.2 environment. Remains to be seen if that will ever happen, but that's our intention. So internally for our applications, I've got about 2,000 modules built, as I mentioned, not so much on VAX right now, but Alpha, Integrity, and x86. A bunch of different versions because some of the programs that we run have version-specific things. So I need to, for example, build against the 7.3-2 environment and build against an 8.2 environment so that when I deploy software, it can run on the correct target system. So initially, we built everything with the cross tools. There is some limitations. Some limitations are pretty significant. And then over time, once we had compilers that were native, I would migrate a component to compile and link natively on x86. There were a few fits and starts here. I can remember we'd get a new, C compiler, and that would introduce a bug so that I couldn't compile native anymore. So we'd go back to compiling in the cross tools, then the compiler bug would be corrected and we'd go back. So there were a few back and forths during field test days. There's a handful of stragglers right now. I'm missing some pieces, primarily SDL. Some of our software uses the structure definition language to build data structures, and that piece of code doesn't exist yet. Some of the open source products that we have incredibly impressive command procedures, which seem to take 5,000 lines of code to compile 5 modules. And I don't know, some of the complexity exceeded my level of enthusiasm. And then there's a few minor issues, a bug here and there, or some interaction between Alpha and Integrity, which didn't fit well with x86. So I will confess I'm not 100% yet. Code changes, I will share with you that almost always the code for alpha and integrity, if you have if-defs and things like that, it's the same on x86. There's probably a few exceptions to that rule, but that should be your expectation. Anything that looks at the hardware model, specifically, you're going to have to address. And if I could look back in 25 years ago, or 30 years ago, wherever I said, if alpha, do something else, do the VAX way, I wish that I had seen the future, because I would have said, if not VAX, then do it the new way, else do it the old way, because that code wouldn't require any changes. But if you have things like get SYI looking at the architecture name or type or hardware model, if def, if non-def, if you use percent bliss, whatever, things like that, compile time checks, you're probably going to have to look at that code. Maybe not change it, but review it and make the alpha and integrity behavior be the same for x86. There may be some edge cases if you're using some built-ins. I found some problems with data structure accesses in some code, some that we wrote, some that we inherited, that didn't quite do the right thing. But again, very, very small and few. So where did I find problems? x86 is not bug for bug compatible with integrity and with alpha. Some of the code that I fixed, and I know that my friends in VMS engineering have fixed, has been broken for decades. We were just always lucky, I guess. And things like uninitialized variables or how the heap gets allocated, the stack looks completely different between the platforms where registers are stored and things like that. So yeah, there have been bugs that have been exposed, but they're not bugs of x86. I had customer talking to me recently, and I explained that just because your program works today doesn't mean there are no bugs. And an uninitialized variable is an excellent example of that. We found all sorts of problems along the way with flaws in OpenVMS field tests, compiler field tests did the wrong thing, and so on. And with our good working relationship with VSI engineering, in nearly every case, those got fixed quickly. There were a couple of them that took, I don't know, over a year to fix. And those were, at least one example was a 30-year-old bug. Increase your quotas. It's not 1982 anymore, so just throw more memory at the problem. Your working set, page file quota, byte lim, things like that. There's a couple of things that you probably won't see. The behavior of signaling a couple of the floating point exceptions, divide by zero, invalid floating point number, arithmetic faults. The behavior is a little different today than it was in the past. It's unlikely you're going to stumble into these conditions in your code, but be aware. If you've got macro 32 is a no-brainer. It almost always works. It's probably going to require a little bit of change, but not that big of a deal. If you've got integrity assembler, alpha macro, x86 assembler, your life became a little more challenging. You're going to have to know a heck of a lot more. And if you have code that knows a lot about the VMS calling standard, what images and objects look like on disk, what the debug information looks like, you're going to have to change. Grab a copy of the OpenVMS calling standard, read it again, and then that's where you're going to start. If you end up being exposed in this areas and don't feel real confident, get in touch with us after the session, and we'll see if we can walk you through some of the easy ones. So one of the first pieces of code that I dealt with outside of our code was TICO, and it was kind of fun. I mentioned this and I shared it with some people at VSI. This is an editor written in 1962 originally. And there's a TicoC freeware program that I downloaded off the internet from wherever TicoC comes from. I had to make a couple of minor adjustments. I don't recall what they were, but it was pretty straightforward. So what is this? Within a couple of months of running VMS on x86, I was running Go, which brought me back to my high school days. And so I felt like a young person again. Customer applications, I've got two examples of ones that we've worked with. The first one is a message passing system as part of a great big international securities exchange that you've heard of. They don't need to go to x86 today, but they need to know that they could. So we got involved and built their application. It's about 100 modules, 100,000 lines of code. All of the changes that I had to make were related to alpha versus integrity versus x86, because this code's been around for a while. Once those changes were made, more or less, I executed their build procedure. It compiled their application and it linked it. I was able to run a couple of their little programs, like reports, that didn't rely on being connected to a securities exchange. They did have an interface with the CA, which used to be Poly Center and probably 3 other names owned by VSI now, Watchdog. And so I created a little stub to just resolve the symbols, routine return success. So that was fun. And then the second one, another coincidentally, customer involved in monetary exchange. They've got an application written in BASIC. And so I built their application. They wanted to move to SSL3, which of course has a different interface with SSL1. So a couple lines of code change and that all worked just fine. Found a couple of basic compiler bugs and worked with VSI engineering to fix those. So today I'm running 922, as I assume everybody else is. I've got a few little pieces that we talked about that prevent me from building everything edge to edge. We talk about third-party applications, some, I don't know, PDF converter or something like that. So those may be edge cases that need to be addressed. Performance, I don't know, it's a little early. I'm going to need some new hardware. I'm going to need a little more time. Compilers will continue to improve in the future, but everything works. So to reiterate, where you'll do some work, build procedures are where most of the time is going to spend. If you're running in inner modes, if you're linking against sysexe, if you know about the format of exceptions and frames and things like that, you'll need to do a little bit of work. If you require strict floating point behavior, this is going to be a little bit of a concern. Macro, besides macro 32, it's time to port that to some high level language, C or Bliss or whatever you like. As and within C, my recommendations avoid it unless you have no choice. So VMS is VMS. That's kind of the upshot of the whole thing. So there's a whole raft of people that I need to thank and acknowledge. I'm sure I've missed many of them, but thank you so much for the opportunity.
Thank you, Norm.
Oh, unscreen share. Thank you all.
Okay, we have a bunch of questions and 13 minutes to address them. So I don't know, Camiel, would you like to start? Just open the Q&A and then start answering. These are mostly questions to VSI, but Norm might want to chime in on some of them.
Sure. Okay, so the first question I see is, when will porting of user-written system services and other privilege mode software be supported for OpenVMS version 9 on x86? It works today, but not everyone has the information needed. And we are working on a like privileged code porting guide. I'm not currently, I don't have it off the top of my head when we're planning to release that. I don't think we've really planned that yet, but we will have something for you. Which cloud provider are we testing on? I think I can tell you that we are working with Oracle, with their Oracle Cloud instances. Why not use the established clustering capabilities given in the virtualization ecospheres? For example, VMware Paravirtual SCSI RDM or clustered VMDK, much greater flexibility. We have looked at that, and there's a variety of different techniques that hypervisors and virtual platforms offer to share disks between virtual machines. But certainly not all of them will work for OpenVMS clusters. One of the SCSI features that we rely on for our clusters is tag command queuing. And that doesn't translate well in every virtual environment if you use it like that. So we'd rather spend our time figuring out something that works across the board, but we are also looking into these. So there may be some of these techniques that we will support in the future, but certainly not all of them. How much of the original bare metal fiber channel and network support back when VSI was working on ProLiant hardware target systems does v9.2-3 use/leverage? My answer would be all of it. And in fact, we leverage a lot of the driver development that was done for Itanium. So if you have a fiber channel card that was supported on Itanium, there's a pretty big chance that if you put that card into an x86 system, that it will work. It may not be supported, but so we do leverage that. Is there a version of Tico that runs on an x86? I think Norm answered that. It's not real Tico, it's Tico written in C, but it's got to be good enough. We send binary data to PLCs via TCP/IP, so alignment is very important. The code that creates these data packets is written in Fortran 19 on an Itanium. They have IEEE, real 4 and real 8, integer 2, 4, and 8 and ASCII data. Will our code work with just a recompile on x86, or will we have to change our code to match the current data layout? Now, I'm not a compiler expert. I know a little bit about Fortran. I know something about data alignment. My suspicion is that it will probably work. I will verify that answer with John Reagan, but you should try it. When will be the documentation on VMS version 9 x86 internals? We will provide the information that you need to create privileged applications. I don't think we're going to see something like the internals and data structures manual updated for x86. I think that's out of scope. Could you please elaborate on Polycenter Watchdog being owned by VSI again? If confirmed, what are the plans? I'm looking at Daria for this one. Is this part of what we acquired from Broadcom?
Yes, this is part of what we've acquired. If I am not mistaken, Watchdog is the product that's written in Ada. And if it's so, then we are unfortunately not bringing Ada to x86, and then consequently we'll support Watchdog on integrity, but we will not bring it to x86 either, unless we decide to port Ada. But let me verify and get back to you with more precise plans on Watchdog.
Okay. I see a question on Oracle RDB availability. That is something you have to ask Oracle. While we work very closely with Oracle, we have no say over their schedule. For RMS, is there a plan to extend the record size limit from current 32 kilobyte to higher? I don't think so, but I'll verify that. The application I support is written in BASIC. What is the current state of play with the BASIC compiler for x86? I believe our BASIC compiler is in field test.
Ah.
I see Daria nodding, so I'm sure that that's right. When will there be another US-based OpenVMS bootcamp? There probably will not be a bootcamp, but there will be something. I don't think we're going to revive the name bootcamp, but we'll try to revive the spirit of the bootcamps.
Yes, we are planning on an event this fall, and we will definitely update you sooner, probably sometime in June. We'll let you know when we're having an event.
Okay, and I think that was the last question.
Yes. And then there is another one about Nutanix.
Nutanix. At the moment, no. Running OpenVMS x86 on Nutanix, we don't support it because we do not have a Nutanix environment. If you do have a Nutanix environment and you can share some of your experiences with us, that would be great.
Okay. And then we have some questions in the chat.
Do we?
Yes, just at least I'm seeing the latest one from Edgar. We see the great effort that Camiel makes in the technical part, but how is the sales and marketing area supporting him? What is the strategy to push version 9 into the market just to keep current customers, or is it intended to reach new clients? Okay, I can take that one. And as I've already mentioned in the previous webinar, our main goal for 2024 is to bring our existing customers to x86. We see this as the most important goal for our company, because if our customers come to us with to x86, then we still have our customers. But if they don't come with us to x86, then their hardware is no longer supported, and they might have to make other arrangements and other decisions ultimately. So this is our main goal for now. We might build a strategy to reach new clients, but only after we've secured a good proportion of the existing customer base on x86. That is my answer.
Yeah, and I can maybe add to that that I work very closely with the sales team in my new role. So Jan and we talk. I talk to the people who are in sales probably more than I talk to some of the engineers, and that is because I need to understand what it is that our customers are asking from us, and then we need to turn that into a strategy. And turning that into a strategy doesn't necessarily mean that everything our customers ask for is what we're going to do. For instance, when we get requests to support Dell hardware and Cisco hardware to run OpenVMS on, and our telling those customers yes would mean that other features of the OS get delayed by a year, it's probably not in the customer's best interest to say yes to those questions. So I see more questions are popping up still. Oracle client on x86. Again, you'll have to ask Oracle. I don't think that that is going to happen before we have RDB, though. If it's going to happen, that is. Which one is the preferable, VMDK or the ISO file for OpenVMS 9.2-2? So I think the VMDK is probably the community kit that we put out, but if you're installing OpenVMS, you want to use the ISO file.
Okay, and then there is a question in the chat again.
Okay.
A couple of those. On RDB, that's probably more of a comment, but then SQL Relay, SQL Relay.
Is SQL Relay the replacement for Oracle Client on OpenVMS? I do not know. I'll have to get back to you on that. We'll add it to our list of questions for the webinar.
Yes, we will try. Actually, all of the questions that we've already answered on this webinar, we will also add to the list of questions and answers and send it out to you guys so you can reference that.
Okay.
And there's more. A joint webinar with Oracle. Yes, we will discuss this with Oracle at some point when they're ready to join the webinar with us. So it's not out of the question, but we don't have a date for you yet.
Is there an end of support date for the current Itanium hardware? I believe there is. I believe HPE has put that at the end of next year, if I'm not mistaken.
Yes. Yeah, that would be my guess too, but we'll verify that. Okay. Not sure what Sumit meant, but you are welcome.
I think that's the joint webinar with Oracle.
Okay. Great. Yes. As soon as we have more information on that, we'll update you. We're actually having a meeting with Oracle later this month, so maybe we can discuss the date there.
All right.
Okay. Can they be shared with Git, GitHub, or containers like Docker? I am not sure what you mean by they, but I guess we're at the top of the hour. So Edgar, if you could reach out to us via email and clarify what you mean by they, then we'll definitely be able to answer your question and add it to the Q&A. But thanks everyone. And in particular, Camiel and Norm, thank you for great presentations.
Thank you so much. We appreciate it very much.
And thanks everyone for attending.
Right. Thank you. Have a great day. Bye now.